Okay, in that case, I'm going to ask Chris Lawrence to join me, and we're going to talk about Mojaloop and the Interledger Foundation.
Hello.
Hey, here we are. So, this is about connecting Rafiki, connecting individual institutions to Mojaloop, external individual institutions to Mojaloop schemes. So our objectives are, first of all, to demonstrate the ability to initiate a payment in a financial institution anywhere on a network that supports the Interledger protocol, which results in a credit to a beneficiary's account at a financial institution which is a member of a Mojaloop scheme. We're thinking about going the other way as well, but not yet. Second, to make it easy for any Mojaloop scheme to add plug-and-play access between their scheme and any financial institution that uses Rafiki. And third, to enable any financial institution that uses Rafiki to get access to any Rafiki-enabled Mojaloop scheme, and through that to its participants. So I'm going to pass you over now to Chris, who's going to talk a little bit about the Interledger Foundation and its work.
If the clicker agrees.
Yeah, if the clicker agrees. It's going so well.
Well, heck. I know everybody is hungry, and we've done a lot of talking and thinking this morning, so I'll be quick about this. My name is Chris Lawrence. I am the head of programs at Interledger Foundation. I'm not going to read this to you. It's good copy. You can check us out there. But Interledger Foundation is going to celebrate our 3-year birthday in July. We were basically started as a nonprofit to advance the use and integration of the Interledger protocol and the tools and systems that it enables. We do that through strategic partnerships, strategic grants, and really funding innovation within the system. And you're going to hear a little bit more about that here in a second. We're going to get People's Clearinghouse to do a demo where they actually walk through these linkages. And ThistaWorks, who you heard from earlier, is a grantee of ours as well, working towards these issues. So, we're really dedicated to financial inclusion, and that's where all of our work really comes from that. A quick look at the protocol. It's an open source protocol that enables payments. Arunjay mentioned earlier, it's kind of one of our taglines too. You can find our cool, fun, animated video on our website, interledger.org. But we want this idea of making payments as easy as sending an email through open protocols is, essentially a reason that we exist. And again, through grant making and resources and communities of entrepreneurs, artists, creators, etc., we bring that community together. There's obviously a lot of intersection between the Mojaloop community and ours, both philosophically, emotionally, and technically. All right.
I'm trying.
Gave it the old college try, Michael. There we go. Interledger Network, as a technical idea, is this system of interoperable services that once starts to use Interledger protocol in some way enters the network, and we're growing how many of those nodes that we can build and make that a robust network of all kinds of different tooling and systems. We're a big believer in local solutions and funding and starting from local solutions and working to global application. So as we do this, I'll hand this over to Michael and our CTO, Alex Lakatos, who I hope, I'm dreaming, is on the video. Longtime friends, Interledger, when it was just simply a protocol, and the Gates Foundation days with Mojaloop, so this is a long connection in history. We are currently supporting Mojaloop to move from their use of V1 of Interledger protocol to the current use of Interledger protocol. We're also supporting Mojaloop as they look into Rafiki, which you're going to hear about in just a few minutes. And as I've already mentioned, some of our grantees sitting here in the room, ThistaWorks and People's Clearinghouse, and they're amongst a cohort of 10 other grants, research and development grants that we made last year to be looking at what are financial services that are in some way touching and using Interledger protocol. This is a 3-phase program. First phase is R&D, so we're going to see some of the results of that R&D. Second phase, which they'll be only be able to apply to, it's not to the world, it's just to that cohort of 12, for a prototyping and piloting phase, and then a launch phase as a third round. And that's an example of the kind of grants that we'll be doing throughout the years on a number of topics. So I'm going to turn it over to Michael, and I said, cross fingers, Alex Lakatos on the video machine, and enjoy. Take it away, Michael.
Thanks very much. So, Rafiki is an API-based protocol which is designed to hide the complexities of streaming based on the Interledger protocol from its participants. It enables simple payments, recurring payments, app-based payments, and advanced payments. And it allows payments to be specified and executed as a whole payment rather than at the interledger or packet level. So previously, organizations that wanted to make transfers using Interledger had to do some quite complex management of streams, making sure they were open, finding out what was going on. And all of that is hidden by the Rafiki protocol. It's still going on underneath, but participating institutions don't need to know about it. Oh. So this is our aspiration. We'll have a sending FI, financial institution, which will use Rafiki. Its transaction processor will initiate payments in Rafiki, and that Rafiki instance will talk to another Rafiki instance at a cross-network provider, which is attached to a modular loop scheme. That Rafiki instance will talk to the transaction processor in the cross-network provider, which will manage the connections across to the modular loop scheme itself, giving a seamless access to participants in the modular loop scheme to the originating institution. So that, as I say, is our aspiration. We're a little way from that at the moment, but the big question, what are we missing? Settlement. Rafiki protocol is about clearing, it's about transferring obligations, it's not about settling. Now, the great good fortune that we have in the instance we're talking about, you'll find out about that in the future, is that we've got the settlement side covered. But it's going to be a problem with generalized adoption of this, that people will have to have, I think, a much better way of settling between institutions and schemes. So, but we're not going to talk about that now. So, discovery, I'm going to move through this very fast. The phases of a transfer. Rafiki sees this as setting up a payment. The idea is that the debtor transaction processor requests payment setup. The debtor Rafiki instance contacts the cross-network provider's Rafiki instance to set the payment up, and that Rafiki instance then contacts the transaction processor, which can do the modular loop address resolution process, as it normally happens, and respond either with success or failure. It can also, for instance, include some KYC information. The structures are not there yet in the Rafiki interface, but there are kludges available where we can use string fields to contain, for instance, JSON objects containing the KYC information. I know, I feel dirty. Okay. Agreement. Now, things are slightly more complicated here because Rafiki has a resource to allow a sending party to obtain a quote for the cost and conversion rate for a transfer. But in MVP, there won't be any of that. But currently, this works entirely in the Rafiki network. So it expects a Rafiki instance to contain information about what it will charge, because it's not used, I think, to thinking of the Rafiki instance as the representative of numerous participants, for instance, in a modular loop scheme, each of whom may charge different things. So again, it's the similar thing to the question that Min talked about in the proof of concept. Most of these existing solutions are not very used to the idea of variable charges which are set per transfer. So that's something we have to think about. Then finally, go on. There we are. So once the payment's been set up, Rafiki will just start passing funds through the channel. When that's complete, the receiver instance can generate a webhook and send it to anywhere you want to, basically. This is configured as part of the setup for the Rafiki instance, and it means that the transaction processor at the CNP can be notified that a payment is now complete. But what there isn't at the moment, because there isn't in webhooks generally, is any way for the Mojaloop instance to report back on whether the payment in the Mojaloop scheme succeeded or failed. Now, obviously, that's fundamentally important for how this will work. For the moment, we have another, I'm going to ask Miller to close his ears now because we've got another dirty workaround for this in our original proof of concept, which is basically to provide a callback in the original payment setup, again in one of the text fields, and have the cross-network provider make a call back to that address with the information about how the payment went. I know. But it's all going to get much better, like everything in this life. So, what sorts of issues do we think we want to foreground? First of all, in a world where a lot of Rafiki clients, thousands, maybe millions of them, will be sending to many Mojaloop schemes, how will the client know which Mojaloop scheme to contact? Because generally speaking, we want to, as I say, to find ways of resolving by identifier and not already knowing where we're going to send a payment. How will the Mojaloop scheme obtain information about the sender? Now, typically, Rafiki is not very interested in passing that information. It doesn't see it as any of the business of the receiving institution to know anything about the sender. But we need that, so we'll have to look at that. We need to open the quotation process, as I've already said, to a per transfer Mojaloop quotation. And we need to think in a bit more detail about whether we want to maintain an end-to-end cryptographic guarantee for a transfer which uses this route. Now, the way in which the ILP protocol works is that the condition fulfillment pairs, the cryptographic guarantees of a transfer, are between the individual participants in the chain. And there isn't, so if you get a message, the only thing you want to know is, did the person next to that in the chain send the message or not? It doesn't cover the end-to-end guarantees that we want for the Mojaloop purposes, which are able to say, did the eventual beneficiary institution make the payment and send the cryptographic fulfillment back? So those are things that we will need to be thinking about in the future. Now, we've got a proof of concept, which we'll be talking about in a minute. Am I going to pass this to you?